Welcome to G Fun Facts Online, where we unpack the amazing stories behind science and technology. Today, we're heading into orbit, 250 miles above our heads. Hurtling through the vacuum of space at 5 miles per second is the single most expensive and complex object humanity has ever built, the International Space Station. For more than 2 decades, it's been a beacon of peaceful collaboration, a place where astronauts and cosmonauts from rival nations have lived and worked together, sharing meals, missions, and a view of our planet that transcends politics. But that era of unprecedented cooperation is being challenged. As tensions flare up on Earth and a new, more crowded space race begins, the future of our presence in the cosmos is being rewritten. This is the story of the ISS, a testament to what we can achieve together, and a battlefield for a new contest to dominate the final frontier. It's a tale of 2 competing narratives, one of a resilient partnership and another of a new race for the stars that will define humanity's future. So how did we go from bitter Cold War enemies pointing rockets at each other to orbital partners relying on each other for survival? The story begins with the end of the Cold War. The decades-long struggle for technological and ideological supremacy between the United States and the Soviet Union was over. With the USSR's dissolution in 1991, the purely competitive drive for space dominance faded. Building a permanent human outpost in orbit was the next logical step, but the cost was staggering. Suddenly, an alliance wasn't just possible, it was practical. This shift didn't happen overnight. It was built on trust forged by earlier programs, most famously the Apollo-Soyuz test project in 1975. That mission saw the first ever international spacecraft docking and a symbolic handshake in space that signaled a thaw in orbital relations. That spirit was rekindled in the early 90s. Both America's Space Station Freedom and Russia's planned Mir 2 station were struggling with budget cuts. So, in 1993, U.S. Vice President Al Gore and Russian Prime Minister Viktor Chernomyrdin announced a groundbreaking decision: they would merge their programs. This led to the crucial Shuttle Mir program. Between 1994 and 1998, American space shuttles docked with Russia's Mir space station 11 times. 7 American astronauts lived and worked alongside Russian cosmonauts, learning the ropes of long-duration spaceflight. This phase was invaluable. It gave both nations the practical experience of working together in the unforgiving environment of space, building the operational and personal trust needed for the massive project ahead. With that foundation laid, the International Space Station became a reality. In 1998, 15 nations signed the International Space Station Intergovernmental Agreement. This treaty established the legal framework for a permanently inhabited civil space station, dedicated to peaceful purposes. It was a legal marvel, detailing ownership of modules, rights to resources, and shared responsibilities for keeping the station running. The station's very design is a physical symbol of this partnership. It's divided into 2 main parts: the Russian orbital segment, or RAR-OS, and the U.S. orbital segment, or USOS. The Russian segment provides the station's primary propulsion. It's the engine that keeps the 500-ton structure in orbit and steers it away from space debris. The U.S. segment, which includes modules from Europe, Japan, and Canada, provides most of the station's electrical power and is the primary hub for scientific research. This interdependence was a deliberate choice, designed to bind the partners together. You can't have one without the other. On November 20, 1998, a Russian rocket launched the first module, Zarya. 2 weeks later, the Space Shuttle Endeavour delivered the American Unity node. They were joined together, and the construction of humanity's shared home in space officially began. But the ISS is so much more than a political symbol. It is the most advanced and unique laboratory ever built. For over 20 years, its microgravity environment has hosted more than 3,000 experiments from over 100 countries, leading to breakthroughs that would be impossible on Earth. One of the biggest areas of research is medicine. In space, the human body experiences an accelerated version of aging. Astronauts lose bone density and muscle mass much faster than they would on Earth. While this is a problem for them, it provides a perfect model for studying age-related diseases. Research on the ISS has given us new insights into Alzheimer's, Parkinson's, cancer, and heart disease. For example, studying how protein clusters form in microgravity has directly aided Alzheimer's research. And by observing the growth of certain cells that are crucial for tumor formation, scientists have advanced cancer studies. It's also been a hotbed for new technology and materials. An early German-Russian experiment studying plasma crystals has been one of the station's longest-running and most successful projects, leading to over 100 scientific papers. Another incredible discovery was the existence of cool flames, a type of combustion that happens at much lower temperatures. This discovery, which came from an experiment designed to study how to put out fires in space, could lead to more efficient and less polluting engines back here on Earth. From its perch 250 miles up, the ISS also gives us an unparalleled view of our own planet. Instruments on board help track natural disasters like hurricanes and wildfires, monitor the effects of climate change, and provide crucial data about our atmosphere. At the same time, it looks outward into the cosmos. The Alpha Magnetic Spectrometer, a massive particle physics detector mounted on the station, has analyzed over 100 billion cosmic particles, hunting for clues about dark matter and the fundamental composition of our universe. And crucially, the ISS is our stepping stone to the stars. It is the proving ground for long-duration spaceflight. Every lesson we learn about life support, about recycling 93% of the water on board, about growing food in space, and about the psychological toll of living in a tin can for months on end, is essential for planning future crewed missions to the Moon and Mars under NASA's Artemis program. While the ISS remains a model of cooperation, the world of space exploration around it has changed dramatically. We are in a new space race, but this one is completely different from the Cold War. It's a multipolar, multifaceted contest with a whole new cast of characters. The biggest change is the explosion of the private space industry. A few decades ago, space was the exclusive domain of governments. Today, there are over 12,000 space-focused companies, and they are changing everything. NASA has been a key driver of this change. After the Space Shuttle was retired in 2011, NASA needed a new way to get supplies and astronauts to the ISS. Through its commercial resupply services contracts, companies like SpaceX and Northrop Grumman became the station's lifeline, running cargo missions like a cosmic delivery service. But the real game-changer was the Commercial Crew Program. NASA awarded contracts to Boeing and SpaceX to develop American spacecraft to transport astronauts, ending years of complete reliance on Russia's Soyuz capsules. This space taxi model, where NASA buys a ride instead of owning the vehicle, has not only saved money, but has also kickstarted a brand new industry in commercial human spaceflight. This commercialization is now shaping the future. The ISS is set to be retired around 2030, and NASA is actively funding private companies to build its replacement. Several ambitious projects are already underway. Axiom Space is building the world's first commercial station by first attaching its own modules to the ISS and then detaching to become a free-flying outpost. Orbital Reef, led by Jeff Bezos' Blue Origin and Sierra Space, is envisioned as a mixed-use business park in space for research and tourism. And Starlab, a joint venture between Voyager Space and aerospace giant Airbus, is planned as a dedicated research lab that can be launched on a single rocket. This shift from a single government outpost to multiple commercial destinations is a fundamental change in how we will live and work in orbit. But it's not just companies. A new group of nations is making its mark. China, which was excluded from the ISS partnership by US law, has forged its own path. Its Tiangong space station has been operational since 2022. While smaller than the ISS, it's modern, and China is actively marketing it as a platform for international collaboration, creating a direct alternative to the Western-led model. In a major geopolitical move, Russia and China have announced a partnership to build an international lunar research station. They plan to construct a permanent robotic base on the Moon's south pole by 2036, creating a distinct block in the race back to the Moon. And then there's India, which has emerged as a major space power after becoming the first nation to land a craft near the Moon's south pole. India is now planning its own space station, the Bharatiya Antariksh Station, aiming for completion by 2035 and sending an astronaut to the Moon by 2040. The ISS has long been praised as a sanctuary from politics on Earth, a shining example of science diplomacy. But the Russian invasion of Ukraine in 2022 put that ideal to its most severe test. The partnership didn't break, but it was deeply damaged. In response to Western sanctions, the former head of Russia's space agency, Dmitry Rogozin, unleashed a storm of threats. He repeatedly suggested Russia would pull out of the ISS and, in a thinly veiled threat, reminded the world that Russian propulsion is what keeps the station from falling out of the sky. "If you block cooperation with us," he tweeted, "who will save the ISS from an uncontrolled deorbit?" These threats, while mostly dismissed as political bluster, highlighted the station's fragile interdependencies. In one particularly jarring incident, Russian cosmonauts posed for photos on the station, holding the flags of Russian-backed separatist regions in Ukraine. This prompted a rare and sharp public rebuke from NASA and its European partners for using the station for political propaganda. Despite all the vitriol, the day-to-day professional work in orbit has continued. It has to. The safety of the crew depends on it. But the trust that was the bedrock of the partnership has been shattered. Russia has announced it intends to leave the station after 2028 to build its own. And in a clear sign of the new reality, NASA has started testing ways to use commercial cargo ships to reboost the station's orbit, preparing for a future without Russian propulsion. As we look beyond low Earth orbit, two distinct paths for the future are emerging. On one side are the Artemis Accords. This is a US-led set of principles for peaceful and responsible space exploration. Dozens of nations, from Japan and Canada to India and the UAE, have signed on, creating a broad coalition for the next era of exploration. On the other side is the China-Russia Lunar Base Initiative. This partnership presents a direct alternative to the US-led framework, built on a vision of a more multipolar world. This divergence is setting the stage for a new kind of space race, one fought not just with rockets but with competing norms, standards, and spheres of influence. The International Space Station is now in the twilight of its life. Around 2031, it will be guided to a controlled splashdown in a remote part of the Pacific Ocean, but its legacy will endure long after its fiery re-entry. It will be remembered not just for the science it produced, but for the profound lesson it taught us, that even in a world of conflict, collaboration on a grand scale is possible. The new space race is more crowded, more commercial, and more complex. The final frontier is fracturing along geopolitical lines. And yet, the quiet, professional cooperation that continues 250 miles up, day in and day out, offers a glimmer of hope. It's a reminder that our shared destiny in the cosmos may ultimately depend not on who wins the race, but on how we choose to run it. Thanks for joining us on Fun Facts Online. Well, see you next time.